So I want to share just a little bit about the Way Anova today. So the Way Anova helps us find differences between unrelated groups. And when the research question has three or more unrelated groups different from one another, we need to use the Way Anova. So some examples might be comparing the effect of alcohol consumption on the risk for heart disease among people with and without diabetes, examining the effect of gender and type of health insurance on the number of physician visits made each year. And so when we look at these types of research questions, we're looking at more than three groups. And so some of our other tests wouldn't allow for this because we only can look at the difference between two groups. So this test allows us to look at the difference between three or more groups. So when we look at the variables that we would use with the Way Anova, our independent variable, or our grouping variable as the text calls it, defines the groups that we're going to be comparing. And so the groups will be compared by the different levels of each of these factors. So when we talk about type of insurance, we might be looking at variables that have three types of insurance. And so here in this example, the factors are gender and insurance status. And so when we look at that, we may define gender in a dichotomous way, or we may define gender in a more inclusive way and have multiple selections for gender, and then insurance status, depending on what variables we're looking at, may include more than one answer. So if we chose to just look at gender in a dichotomous way, and our variables that we are looking for insurance, either no insurance, Medicare, TRICARE, or private insurance. And so we have 4 different levels of insurance, and then gender, we have 2 different levels. So we have a total of 8 groups. So we have men without insurance, women without insurance, men with Medicare, women with Medicare, and etc. Each study participant is only in one of these groups, so that they fit into one of the 8 groups that we have defined by our variables. What the Way Anova test does is it compares group means. And so we're looking at means, and this again is for normally distributed data, parametric data. 3 sets of means are compared. We would compare the mean number of physician visits in each of the 8 groups. So in each of those 8 groups, we would have a mean number of visits, and that's referred to as the interaction effect. We would have the mean number of visits by gender for each gender, so that's 2 different means, and then the mean number of physician visits for insurance type, and that would be 4 different means. So our research question in this example is the mean number of physician visits made in a year affected by gender and insurance type? So that's the question that we're looking at. What this really boils down to is 3 different questions. Does the mean number of physician visits differ by the level of insurance? Does the mean number of physician visits differ on gender? And then, is there an interaction effect from the intersection of insurance and gender on the number of physician visits? So when we look at this, our independent variables are gender and insurance type. Gender has 2 levels and insurance type has 4 levels. The dependent variable is the number of physician visits made in the past year. So an Way Anova is an appropriate test for this type of data because we're comparing the means of 4 or more different groups defined by 2 or more grouping variables. This is for parametric data. It assumes homogeneity of variance between the groups so that the groups are all very similar, and reports in means and standard deviations, similar to our other parametric tests. So to think about it, how many groups are defined by the variable gender, 2 levels, and smoking status, never, former, current, and current smoker. So how many total groups would we have in this example? The answer is 6. So the total number of groups is 6 because we take the number of levels in the first factor times the number of levels in the second factor, and that gives us 6. So just in summary, I want to go back to talking about when you would use this would be when we're looking at the means of 3 or more unrelated groups and looking to see if they are different from each other. And that is when you would use the Way Anova.